All right, we are on Unit 4, Day 8 notes. This is, of course, these are our objectives up top. These are the subject areas we'll be going over. Many problems have multiple objectives in them, so just be aware of that. As always, I say it on every video just to remind you, just in case you want to watch just the videos basically that you don't understand as opposed to every single one. All right, so first and foremost, let's start here with write the following as an inequality. 8 is greater than or equal to W, and 1 is less than or equal to W. And they want to use W only once, okay? When you see the and or when you're talking about these inequalities do matter, okay? Or you'll usually see two variables, and with the and you'll just see one, and I will show you how in a second, okay? All right, so 8 is greater than or equal to W, 8 greater than or equal to W, and we also have 1 is and 1 is less than or equal to W, okay? And we want to write 1W, right? So just 1W. So we know that we have 8 and 1, so 8 is here, 1 is here. Usually with your and problems, this is how you'll see them, numbers on the outside and then that letter in the middle. We know that W in respect to 8, the W, you see how the mouth, I would say, because it opens up towards the 8 in that situation. So I'm going to keep that the same. The mouth kind of opens up towards the 8. That is greater than on that side. But in this case with the W, the mouth opens up towards the W. So when the W's on this side, it's still going to open up towards the W, which means this one, W is greater than. W is the mouth that's open towards. So W is the one where that's bigger or it's greater. So in this case, 1 is less than or equal to W. Okay. But when we have the W on this side and the 1 on this side, it's still going to be opened up towards the W. So that's how you get the problem for this particular, the answer for this particular problem. The W's in the middle didn't change here, but it kind of looks like it changed there. It really did not. It's open towards the W here. When the W flipped over here, it's still open towards the W. Okay, that'll be your answer there. Let's try another one. Although it doesn't have a star, let's try it again. All right. So we said the 9 is here, W is in the middle, and it looks like 5 is on the end. Okay. Here it says 9 is greater than or equal to W. Here it says 5 is less than W. All right. And I put the 9 and the 5 here, W in the middle. Of course, the mouth is opened up towards the 9 there, but as you see, the W has the mouth open up towards it. The 5 is basically less than. 5 is less than W. So here, same thing. Mouth is still opened up towards the W when it's in the middle. So your answer will be that. Got it? All right, graph the compound inequality on the number line. So I'm going to graph it on the number line. Now, what's important to know for this particular situation is the number line. So what number comes first on the number line? That is what you're going to put here. So you know, if you start, let's say you start with 0, and then you'll have 1, and then you'll have 2, and then you'll have 3, and then you'll have 4, and then you'll have 5, and then you'll have 6. Of course. So graphing understanding the number line is important. In this particular one, 6 is on this side, although it looks like it's on this side on the or look at it, 6 is here. So closed circle because it has a line under it, and of course I already showed you how to do this. The arrow, it looks like it's going to go that way, so this way, okay? And then for the 3, closed circle, again, because the line under, the arrow goes that way. So this is what our or problem is usually going to look like, usually. All right, so let's look at the next one. Graph the compound inequality on the number line, of course, again, and this one says and. Okay, let's see what that kind of, how that changes. You should know that the 3 is going to be here, 4, 5, 6, 7, 8, 8 is here. Okay, so it doesn't really, you don't have to really show in between. On Alex, they'll probably have a real number line and you can put the numbers there. I mean, you can put it there. So 3, I mean, if you have the 8 opened and it looks like it's going this way, so usually that way, and then the 3 closed, okay, and it looks like it's going that way. So basically in between, when you have the and, usually in between them is going to be where that line connects or the shading is, okay? All right, let's look here. Write the compound inequality for each graph shown. All right, as you can see, this is an and problem. This one is an or. How do we know? Because and are usually kind of like conjointed this way, kind of like we did here. Ors are going to look like that for the most part. All right, so this one is an and problem. So with the and problem, we can write it separately, but we need to make it look like we did at the very beginning when they're kind of conjointed. There's only one variable, okay? So for this one, if I'm writing the and, I'll put the letter, so I'll put the 2 numbers on the outside, okay? I'm going to put the 2 numbers on the outside and then I'll put the letter on the inside, okay? So for this particular one, understand that it's going this way. It really helps me to draw those arrows so that I know which way to put my inequality, okay? So for this particular one, it would be 5, and then I have this for my x, okay? That's what it would kind of look like. And for this particular one, all right, it looks like that, and my x is on this side, and it looks like it's less than 7, okay? So my x, if my x would be in the middle, x would be less than 7 in that particular case, okay? So how am I going to put that? I'll put my 5 is greater than, so x is greater than, and then here I would put my, no, that's not correct. All right, so your x value here is less than 5, I'm sorry, okay? I mean greater than 5, I apologize. So in this case, do you see how it goes? It goes right here to the left. All these numbers are bigger than 5, so it will be x is greater than 5 here. And in this case, my x will be less than 5, less than 7, because all these numbers are smaller than 7. Okay, so when I have to kind of flip it on this case. On this one, as you see, x, the opening is to the 7. Okay, my opening is to the 7, the kind of like the mouth opening is to the 7. And in this case, the x has the opening. So my x would have the opening there. Sorry about that. All right, so that would be our answer for this situation. And here, because it's closed, I will have a line under for the 7. Okay, no line here because, as you see, it's an open circle. Or is easier, of course. So for your ors, x, in this case, less than -7, or this case, x greater than -1. Okay, and then as you see, the closed circles, both of them are going to have a line under it. So the ors are pretty much easier than than these. Let me give you another one. Let's say that we had like open here, and it was like that. Okay, so I'm just gonna just have one off the top of my head. And let's try that again to make sure that we really, really understand that. So both of these are open, okay? So no lines under. So now, you know you're moving this way. X is going to be what? Greater than -9. So you're always going to, whatever this little thing is, you're always going to put X on the left-hand side, and it's going to be greater than -9. In this case, X is going to be, looks like, less than -5. So we know we're going to have -9, we're going to have X, and we're going to have 5. This is only for your and. All right. Here, mouth is open towards the X, so the mouth will be open towards the X. Here, the mouth is open towards the -5, so the mouth is going to be open towards the -5. So this is going to be what your and looks like, and inequality, compound inequality looks like. Okay, so that's how you do that there. All right, let's move on to the next page of your notes. Let's go down here to the middle. All right, it says graph the set X. This is in set builder notation. Okay, so it says graph the set X. Well, is this the last page? No, this is it. I'm sorry. X such that X is greater than 3 on the number line, then write the set using interval notation. All right, let's do that. So for this particular problem, if I had to graph this, of course, at 3, I'd have an open circle, okay? And I'm going to be moving in this direction. I can tell by the arrow. Okay, the arrow's moving in that direction. When you know, if you have that, the arrow is going to be going that way, okay? Then it says graph the set and write the set in interval notation. So what you need to know about interval notation, if there is an open circle, you're going to have a parentheses. If there's a closed circle, you're going to have a bracket. You also should know that if you have infinity is always has a parentheses with it, okay? And depending on what side it's on, okay? So in this particular case, it looks like you're going from 3, and it's an open circle, so from 3, okay? And I'm putting that parentheses because it's an open circle, so it has a parentheses. 2, and if it's an arrow that goes on forever this way, it goes to infinity. 3 to infinity, infinity always has a parentheses with it. So that is your interval notation in this particular situation. Okay. I want to make sure, let me look back to make sure I did all of the problems on the first page. For some reason, I feel like I missed one. I feel like I missed something on that first page. Let me make sure. Where did I just put that page? I'm sorry. I just want to make sure that I did not miss anything on the first page that I should have been going over with you guys. Okay, well, for some reason, I cannot find that first page that I just put somewhere. Well, I think I put it right here. No, looks like it's, I think I did. I think I did everything I need to do. I just wanted to make sure. All right, so that's what we did there. So now let's look at the next one. And of course, it wants you to do the same thing. You are going to graph it and on the number line and then write the set using interval notation. So let's do that. We know that it's going to be 5 and 7, so we can go ahead and put little circles over 5 and 7 because this is definitely going to be in between the two, and no lines under, so that's why I'm not shading it in, okay? So if you're usually you're right in between, but you want to make sure if this is X is greater than 5, all numbers greater than 5 will go this way, and all numbers less than 7 would go this way. So you know that this is going to basically look like that. Usually when it's like this, that's what it is. It's in between. Okay, it's an and. This is an and compound inequality. So your interval notation, it said it goes basically this goes from 5 to 7. Okay, it does go from 5 to 7. And since they have open circles, like we said earlier, open circles are going to be parentheses. So this is going to be your interval notation for this situation there. Okay. All right. So let's move on to this problem here. Okay. And for each value of B, determine whether it is a solution to this or not. And we will see by, first and foremost, we have to solve the problem. So it's 9 plus 2b is greater than 15. Okay. So let's get, we solve this like we would solve an equation. We're going to get rid of the 9 first. Okay. 2b is greater than 15 minus 9. I want to say that's 6, I don't know. 15 minus 9 is 6. Yep. 6. Divide by 2 on both sides, you get b. And again, you're dividing. If you're subtracting, you do not change the sign. It stays the same. When you're dividing by positive, the only time you flip the sign is when you're multiplying or dividing by negative. In this case, we divide by positive, so this stays the same. 6 divided by 2 is 3. Okay, so this means that all numbers greater than 3 are solutions. All numbers greater than 3 are solutions of this problem. Okay, so not including 3. So is 3 a solution? No. Is -8 a solution? No. Is -1 a solution? No. Is +9? Yes. 9 is a solution because it is greater than 3. That is how you solve those. Okay, let's look at the next one. Again, solve the equation, the inequality. -3 minus 2, -3u minus 2 is less than or equal to -11. I'm going to add 2 to both sides. -3u less than or equal to -9. Okay. So when you divide both sides by a negative or multiply by both sides by a negative, so you have to have the two negatives here. That is when you're going to flip this sign. Okay, I flip this sign, this becomes +3. So this means all numbers greater than, so this is a greater than +3 are solutions to this problem. Is -1 a solution? No, -1 is not greater than 3 or equal to. 3, is 3 equal to or greater than 3? Yes, it is. So I'm going to say yes there. Is 4 greater than or equal to 3? Yes. Is -3? No. So that will be, those will be your answers there for that particular situation. Okay. Okay, so last page looks like this. And I have the 1 star that we're going to do. You're just basically solving your inequalities. 12 is greater than or equal to u minus 6. We're adding 6 to both sides, and it says simplify your answer as much as possible. 12 plus 6 looks like it's 18, greater than or equal to u. That is your answer. You have to graph it. You should graph it, but you don't in these situations. This says b minus 15 is less than -4. Add 15 to both sides. Okay. B is going to be less than 11, it looks like. +11. Doesn't want you to do anything besides that. And don't be scared of fractions because your calculator can handle that. We already talked about that before. Y minus 1/2 is less than -2/5. If I had to add 1/2 to both sides, I could easily put that in my calculator, and I'm not going to be flipping anything because I didn't multiply or divide by a negative. So for this one, it will be -2. Remember, instead of divide, I'm going to push this A, B, C button, and it will give you like a little backwards L. and a 5 plus, and then I'll push 1, the ABC button, and 2, and it should give you your answer in the form of a fraction, which is 1/10. So your answer is y is less than 1/10. Okay, so that is your Unit 4, Day 8 note.